Today, I want to talk about a material that shows up almost everywhere in the modern world. I'm sure all of us have seen it before, and some of us have probably even touched it without thinking much about it. Take a look at these images. Do you recognize what material I'm talking about? It's carbon fiber. So what exactly is carbon fiber? What makes it so special? And why did humans create it in the first place? Today, let's find out together right here on The Ordinary Mystery. Back in the 19th century, when technology was still very limited, inventors like Joseph Swan and Thomas Edison used carbonized bamboo fibers as filaments in early light bulbs. These were very simple forms of fiber made by heating organic materials until only carbon remained. But at the time, no one thought they were creating some kind of futuristic material. They were simply trying to make a light bulb work. So in a way, the idea of carbon in fiber form appeared surprisingly early, but completely by accident. The real turning point didn't come until after World War II, when aircraft, missiles, and military technology began advancing at a rapid pace. That created a major problem. Traditional materials like steel were strong, but far too heavy. Aluminum was lighter, but in many cases, it still wasn't stiff or efficient enough. What the industry really needed was a material that could deliver extremely high strength and stiffness without adding too much weight. And around that same time, carbon fiber started attracting attention again through research related to replacing tungsten in vacuum tubes. Then, in the late 1950s, scientists began seriously studying carbon in fiber form. In 1958, a scientist named Roger Bacon discovered that carbon, when formed into microscopic fibers, could be incredibly strong, far stronger than most people had imagined. That discovery opened the door to something much bigger. Later on, researchers found that by heating a plastic called polyacrylonitrile, or PAN, they could produce extremely thin fibers made up almost entirely of carbon. By the 1970s, carbon fiber was starting to be used in aerospace and military applications, where cutting weight while maintaining strength was absolutely critical. So, what is carbon fiber really? At its core, carbon fiber is made of extremely thin strands, usually just 5 to 10 micrometers in diameter, even thinner than a human hair. Inside those strands, carbon atoms are bonded together in a tightly organized crystalline structure. You can think of them like long chains lined up almost parallel to the direction of the fiber. Because of that arrangement, when force pulls along the length of the fiber, the load is transferred very efficiently. And that's a big part of why carbon fiber is so strong. These fibers usually aren't used one by one. Instead, they're bundled together into yarns, woven into sheets of fabric, or combined with resin to create what's known as a carbon fiber composite, the material with that distinctive woven pattern you've probably seen before. As technology improved, the production process behind carbon fiber became much more refined. The first step is spinning, where PAN resin is drawn into extremely thin strands. Then comes stabilization, which usually happens in air at around 200 to 300 degrees Celsius. This stage changes the chemical structure of the fibers so they won't melt when exposed to much higher temperatures later on. After that comes the most important stage, carbonization. In this step, the fibers are heated to temperatures above 1000 degrees Celsius in an environment with almost no oxygen. During that process, elements like hydrogen and nitrogen are removed, leaving behind mostly carbon. At the same time, the internal structure becomes much tighter and more ordered. Finally, there's surface treatment, which helps the carbon fiber bond more effectively with resin when making composite materials. And this entire process is one of the main reasons carbon fiber is so expensive. It's complex, energy-intensive, and highly specialized. But despite the price, carbon fiber offers a set of advantages that make it incredibly valuable. In some cases, it can be around 5 times stronger than steel while being much lighter. It also has very high stiffness, which means it resists bending extremely well. It handles temperature changes well, helping it maintain its shape under demanding conditions. It resists corrosion, and unlike many metals, it doesn't rust. One of the most interesting advantages is its design flexibility. Because carbon fiber can be layered in different directions, engineers can tailor the material to be stronger in the exact directions where the load will be greatest. That's something that's much harder to do with traditional metals. But of course, carbon fiber is not perfect. Its biggest downside is cost. Because the manufacturing process is so complicated and energy intensive, carbon fiber remains far more expensive than most common metals. It's also brittle. Unlike metal, which often bends before failing, carbon fiber is more likely to crack or shatter once it goes beyond its limit. Repair is another challenge. When a carbon fiber part is damaged, it often has to be replaced completely rather than repaired the way a metal part might be. Even so, it's impossible to ignore how important carbon fiber has become in modern engineering. In aviation, it helps reduce aircraft weight, which improves fuel efficiency and lowers emissions. In the automotive world, especially in high-performance sports cars, it's used in body panels and chassis components to make vehicles lighter, quicker, and more responsive. In sports equipment, carbon fiber appears in tennis rackets, golf clubs, and racing bicycles, where low weight and high stiffness make a huge difference. And even in everyday products, you can find it in things like phone cases, wallets, and backpacks, not just because it's durable, but also because it has a sleek, modern look. And that is carbon fiber. If you know any other interesting facts about it, feel free to leave them in the comments below. And if you found this video helpful, don't forget to like and subscribe. I'll see you in the next video.